So after discussing the features, attributes and functions of various embedded systems, now we will look at the constraints in an embedded system. This is also very important because we know embedded system is not a general purpose system. It needs to be small, it needs to be power efficient, mostly it should be portable. So let us see what constraints are there and how do we go about those constraints. So embedded architecture describes the process of planning and designing the components inside the embedded processor or an embedded system. So this we have already seen how the architecture is very important when we are planning or developing an embedded system. It is essential to know and understand the architecture of an embedded processor in order to design the system effectively. If we do not have the knowledge about the architecture of the microcontroller or the embedded processor that we are using, we will never be able to design our product or prototype effectively. The internal components of the architecture may or may not be sufficient for system design. That's true. There are many peripherals already present in modern microcontrollers, or there might be already many features in an embedded processor. But depending on the application, those features may not be sufficient for our entire system design. For instance, if you are using a microcontroller that has different peripherals, maybe ADC, DAC, it has serial communication interface, but it does not have any temperature sensor, inbuilt temperature sensor. So obviously we will have to attach a temperature sensor externally. On the other hand, maybe you can find a microcontroller or a company that designs a small embedded processor that has all these things already inbuilt. Maybe it has a small temperature sensor, alright, or the board that the company designs, a small board that already has a temperature sensor. So depending on the application, we will have to study the architecture of our processor, of our board, of our controller, and then decide what additional peripherals are required. Hence, the architecture of the embedded chip definitely provides solution for the following challenges. Size and cost of the embedded system. So obviously, embedded system has to be small and it should be cheap. This we have already discussed. No one is going to buy a mouse that's probably 5,000 or 6,000 rupees because it has a very complicated and very up-to-date processor. That is not required for the functioning of the mouse. आपका माउस बिल्कुल सस्ता होना चाहिए और बस आपका काम करवाना चाहिए, राइट? सो दिस इज वेरी इंपॉर्टेंट. तो जब भी हम अपना एक सिस्टम बनाएंगे, वी विल look for a microcontroller and an embedded processor that is just sufficient for our application. We do not want unnecessary peripherals. We don't want unnecessary modules attached to our microcontroller processor. जो काम करना है उसके लिए sufficient होना चाहिए. Memory also. Why to use a microcontroller that probably has say 2 MB or 4 MB memory when your work will be done in few KBs, right? So all these things depend on the architecture of the processor or the microcontroller we are using. That is why we should study the architecture, we should study the microcontroller that we are planning to use, or depending on our application we should try to look for a microcontroller that will be able to implement our application with the least possible size and cost. Power and memory requirements. So ये भी आपके previous step से ही आता है. जो भी एप्लीकेशन है एकदम मिनिमम पावर में हमें इम्प्लीमेंट करनी है. सेम गोज फॉर मेमोरी रिक्वायरमेंट ऑल्सो. वी डू नॉट नीड एक्स्ट्रा मेमोरी इफ वी सिंपली डोंट हैव द यूज फॉर इट. अननेसेसरली विल बी वेस्टिंग मनी. ठीक है. Safety and reliability, this is another constraint. The device that we are developing or the system that we are developing, that should be safe. It should not be hazardous or dangerous for anyone, for any human or the environment where it is being used. It should be reliable. It should give results at least 98 to 99% of times. It can happen that 1% or 2% it might not be able to process or it might not be able to get exact results. That is okay. But majority of the times it has to give perfect results. It should do what it is supposed to do. Operating environment and other resources required for the system. This is also an important constraint. किस environment में आपका embedded system या microcontroller function करेगा, whether your controller can actually work in those conditions, maybe very high temperature settings, very low temperature setting, very high humidity, moisture content in the air. Then the integration flexibility and interaction with external devices. This is also very important. How well your processor or microcontroller can actually interact with other devices, whatever external peripherals, sensors or actuators we need to use, and how flexible it is in integrating with them. I mean, do you require some other kind of connectors, level converters, voltage converters in order to connect it with some other device? Or you can directly use another peripheral or use any external device with that particular embedded processor or microcontroller. तो कितना flexibility देता है आपको और दूसरे devices के साथ integration और interaction में, right? The number of components in the architecture, their capacity and efficiency depends on the development of technology, application requirement and the manufacture. तो ये हम पहले से ही बात करते आ रहे हैं, जो भी हमारी application requirement है और जो भी manufacturer है, whatever the manufacturer or the developer wants, so number of components, capacity and efficiency is going to depend on that factor. जो हमारा main application है उसके accordingly हमें अपना technology, microcontroller, processor choose करना है. So that is why choosing a microprocessor and microcontroller is very important based on the application and considering all the above constraints. Amount of memory and the type of memory to be used is another important consideration. Why? Because abhi humne discuss kiya, you do not want extra memory for an application that utilizes a very small amount of memory, right? And whether we want to store permanent information or we only have use for volatile memory. So all those memory considerations are very important. Type of architecture is also important, whether we are going to be using von Neumann or Harvard architecture. ये भी एक constraint होता है आपके embedded system में, whether you want to use this architecture or you want to use Harvard architecture.